Yep. Let me know when y'all on there. Oh, can y'all see me? Yeah, y'all can see me. Okay. Ooh, child. Multiple hats. Okay. Everybody can see my screen?
Yes.
Okay. I'm about to start recording. And we are typically expecting more people. But I like to be respectful of everyone's time. Okay, we're recording. Okay. So today is our second session. Last week, or it wasn't last week, one of the benefits, and I actually was just talking to Tonky about this, of y'all is y'all actually kind of get a lot of breaks between your sessions because it's like you fall in on holidays and stuff like that. And I don't like scheduling stuff on holidays because like life. But anyway, so at our last session, we had our introduction where I introduced you all to those essential DML languages, data manipulation language, select, insert, update, delete. Today we're gonna at a very high level go over that. But I also want to reiterate to y'all that most of the work that you're going to be doing when you get your role is like selecting data. You're going to be retrieving data, and it's attributed to the fact that when you get your role, it's always ideal that you are given the least amount of permissions possible because like you don't want to go in there and break anything. So you'll mostly be selecting data. But I do like to go over like everything for y'all so you can understand what everything looks like and how it relates to what you're doing. Um, we're gonna talk about data relationships. We're gonna do data relationships literally every single time because like y'all, that is so important. We're gonna do data relationships and data investigation every single time. You're not gonna ever get on here and we're not gonna do that. So we'll do that. Um, and I'm also the objectives of this session, which are gonna be new to you all, is aggregate functions. Aggregate functions, we're going to get into that's where we get into like the analysis part of data. How many of this? What's the sum of that? What's the count of that? What's the min, max? We're going to get into those. We're going to get into aggregate functions with grouping by or categorizing our data with those calculations. And we're also going to get into logical operators, which is filtering our data. Now, another benefit of today's session is that those logical operators are essentially an extension upon like what we already talked about and what you all already know from last session. So it's going to be a little bit more exposure, but the way that I try to teach is like everything directly relates to something that we've already talked about, and it's just going to challenge you a little bit further each time so you don't get like, oh, overwhelmed. So any questions before we get in this thing? Let's go. So I told y'all that we were going to reiterate what we talked about last week. Last week we got into those DML languages, that basic SQL syntax. If you are navigating within a space of SQL, you're either doing one of four things. You're either selecting your data, inserting data into a table, updating data that already exists in a table, or deleting data from a table. You're doing one of these. 99.9% of the time, you're going to be selecting data. So when we say select, we're saying we are retrieving this data. Select whatever columns that you want from your table, you list out after your select statement. In the example, we have select star. But like I told y'all last time, select star is not best practice. Don't be in your tech sessions doing select star. Don't do that. And it's attributed to the fact of it's not best practice because it uses a lot of memory and stuff. So be very specific in which columns you want from your table. So select, list out your columns from our table. This is our database, this is our schema, and this is our table name. And we're going to talk about that today again as well to make sure y'all understand that. Insert into, same thing, table name. You're always doing something to a table. Everything is going to a table. Insert into table name, list out your columns, and list out your values in those columns. Everything has to match up. Like when humans talk or when most humans communicate, you can say something and I can kind of fill in the gaps on what you're trying to say. Like, okay, well, she meant this. I know she meant that. I know he meant that. I try not to assume what people mean, but y'all know what I'm saying. When you write in your code, it cannot be like that. It has to be super specific. And it can be something small that'll throw everything off. So with this, you have to be intentional on how you're lining up your data and your data types. Update. Update, table name, set. It's no different than how you roller set your hair. Do people still do that? I don't know. But you set this column to this value. Where this column equals this. Where is called a condition. It allows you to filter out data that is explicitly based on this condition. Today, when we do our logical operators are conditions. So I'm honing in on it for y'all as well, because it allows you to be explicit on what you're trying to say. If I have a condition, I need to say where this column equals this. I'm telling you, only apply this change where this condition is met. Delete. Delete from table name. And notice we got our condition here again. Where this column equals John. Where this condition is met. Same is literally the same concept. Where this column equals this. Everything goes back to tables. Everything goes back to columns. You doing something in SQL, it's to a table, it's to a column, and you got to be super explicit because it's not going to try to figure out what you're talking about. It's just going to say you're wrong. I don't know. Any questions on this? Okay. Now, let's get into our logical operators. So within those logical operators are essentially conditions that allow you, logical operators are essentially like the ability for you to combine multiple conditions. Now, realistically, when you get your role, you are not going to just select column from your table, and like you're not going to need all of that data. It's up to you as the analytic professional to say, okay, this is the business question. Okay, I need all the customers that joined between this time, or all the patients that had this diagnosis that went to this doctor, or whatever the business case is. It's your job as an analytic professional to figure out how to take that qualitative ask and quantify it. So what that will look like with you is when you are starting to write your code, you're going to have to filter your data. It's no different than you and I were having a conversation and I'm like, hey, go to the store and get me, I always use milk as an example because it's like the most relatable thing. But if I say, hey, go to the store and get me some milk, that's not specific enough. But if I say, hey, go to the store and get me a half a gallon of unsweetened almond milk, I get Kroger brand because like I'm not buying it. Kroger brand, whatever the case is, I'm giving you those conditions. Those are conditions. Now, you don't frame it like that in your natural language. You think it's just a list of what you need. But in data, it's called conditions because I'm explicitly explaining to you what I need. Conditions within data is literally the exact same thing. I'm telling you this is what I need, but I'm telling you you got to get very specific in being able to retrieve that data for the ask. And the way that you do it is a logical operator because it allows you to filter your data based on multiple conditions. Almond milk, half a gallon, unsweetened, Kroger brand, that's multiple conditions. So the logical operators that we're going to talk about today are and, or, not, between, and in. I'm going to explain to you the different concepts, how it's used. And I'm also going to give you the opportunity to apply it as well. So, and when you're looking at this syntax, what do you think that your output is going to return?
That would be exact, I guess, like exact.
Mm-hmm.
Like, maybe
the IT employees that has a salary of 50,000.
Salary of greater than 50,000, but you like 90% there. Yep.
Okay.
Oh, I didn't even see that part. Sorry.
No, you good. Now, how did you get that? What made you? How did you get that answer, Janisha?
Where it says where, and I see IT and salary, and then the 50,000. I guess I overlooked the greater.
Oh yeah. Okay, that is exactly it. So, did you make that based on your conditions? So that's correct. You say where this column equals this value, and this column is greater than 50,000. And here we have and. And is that logical operator that says all these conditions must be met to be reported back in my output, to be in my output. So where this column equals this, and this column is greater than 50,000. Let me do this real quick. Okay. Yeah. So, and if I say and, if I use and as a logical operator, it ensures that all of those conditions are met. Or when you look at this syntax, what is your what do you expect to be in the output? And what type of business question do you think was asked in order for this code to be written like this?
Find all the employees that work in the IT department or the HR department.
Yep. That was a question. I need a list. Give me a list of all the employees. I need to know if they worked in IT or HR. And somebody went and wrote their code, and that's the thing. Now, if I say or essentially means it mirrors just like our natural language. It can meet this condition, or it can meet that condition. And I'm saying it has to meet this and this. So it gets super specific. Or is essentially like, I don't care. It can mean either this or that. Not is essentially like what it sounds like. Select your columns from your table where not. The column equals IT. Another way you can do this is, I'm going to write in the chat. I can't see my screen, y'all. Oh, there you go. I can say where column, and I can do this value. So I can say where column and then put the equal sign, exclamation point, and then whatever that value is. And it essentially says the exact same thing. Between. Now, between is a really good one, and it's very common as well, because what between does is it allows you to hone in on ranges. Like, let's say you have a question, and for example, this is a good one. They want to know give me a list of all the employees that have a salary between these values. Or give me a list of employees that joined in this date, between this date. Anytime you have a range or need a range of two different values, you need to use between. In. Now, in allows you to check if a value, like different values exist in the same column. Like, let's say you're looking for multiple values in healthcare. I'm looking for all of these different ICD-9 codes, this code, this code, this code, this code. All those values are in the same column. Janisha, you're real estate or finance. In finance, let's say I'm doing like some kind of fraud investigation, and I'm looking for these particular reasons that they are flagged. They could be this reason or that reason or that reason. It could just be multiple values, but they're in the same column. So that's when you use in. Select your column name from your table, where your column, in, and then you essentially list out all of your values. Notice that everything we do literally like builds upon what we already have. So everything we do is just going to build upon it. It's going to build upon it. And that's how you write your code. That's why I'm always big on y'all to like break your code down into like piece by piece. And if you recall, last session, we were selecting data, and then we would test it, and then we would insert it, and then we would test it. Like, it would break it down in piece by piece. Because if you do that, it allows you to insert a condition, then test it. Now build your code on it, then test it. Like, you just literally layer it right on top of each other. And that way you don't get overwhelmed with trying to write 20 lines of code or 30 lines of code. And once, you just break it down piece by piece to answer your questions. Any questions on here? Okay. Who got one? Who said that? Somebody said they got a question.
I was saying no questions.
Oh, okay. Now, let me see. Okay. Now, is everyone able to connect to their VM? Was everyone able to connect to their VM? Okay. So we're going to get in here. Now, let me know when y'all see this view. Okay. Now, okay. So now here we have our server. This is our server. This is the brain. Everything you do is going to be connected to your server. And when you get your first role, you will have multiple servers. Like, you'll have a production server, which is live data. And that's probably the one that like is connected to the dashboards, reporting, all that other good stuff. Then you'll have like a dev, which is like what or QA, which is like where developers and stuff go to practice, or where you will be practicing your code and stuff too, if you are building out a report or a dashboard or whatever. Typically, you don't do that on live data. Like, they have multiple environments for you. So this is the server. Right underneath here, these are our databases. So expand your databases. These black boxes right here are your databases. So for this particular use case, let's go in our healthcare system database. So if you click on that, this is new to you all. I think last week we did the data analytics simplified database. So click on that. Now expand your tables. We have all of our tables here. Now, I told y'all, every time we come here, we're going to talk about data relationships, because your understanding of data relationships is going to leverage you all the way around, whether it is in Excel, Power BI, Python, Tableau, everything, anything in data is going to be dependent upon like your core foundational understanding of how data interacts with each other and like how to leverage it. So let's get into them data relationships again. I'm gonna do this every time till it comes second nature to y'all. Data relationships are the same way how humans are related, data is related. What is the common field? What's the common theme between these two tables? So if you want to do your data investigation, you can do it two ways. You can, and data investigation is another thing that I'm big on y'all about as well. Going to look at your data, going to get familiar with what it actually exists. Can you even answer that question? Do you have access to that data? You know, so when you're doing your data investigation, one way you can do it, extend your columns. And this will give you the columns of them tables. What columns in this table? Not only does it give you the columns, but it allows you to see how the data is defined. Here we got this PK. Y'all remember that PK? Type it in the chat. PK is primary key. Is the unique identifier. Then we got our FK, foreign key. And that FK foreign key is the unique identifier for another table. That is a very common question for interviews. A very common question somebody might ask, well, what's a primary key? What's a foreign key? That's literally what it was. That primary key is the unique identifier for that table. That foreign key is the unique identifier for another table. Some foreign, it's not from there. Same concept. Now, you see these columns here and you see everything is defined. Integer, that's the data type. Null or not null. Not null means it is required. Null means that null can go in there. It can be blank. So this just gives you visibility into the data types. Same way with this doctor's table, you do the same thing. Extend your columns, look at your data, and look how that data is defined within those tables. Another way that you can do your data investigation is you can right-click your table and select your top 1,000 rows. And that'll actually give you visibility to the actual values in that table. Data relationships, the understanding of data relationships is also going to leverage you in your joins and stuff too. And we'll get into joins, not in this session, but in next session. But I do like for y'all to like get familiar with this so you're not like overwhelmed. Okay. So we can right click, expand our table, and this gives us visibility to the actual data that exists in those tables. Now, if you are looking at your tables, what is the data relationship between, what tables are related to the appointments table and how? What's the data relationship?
Could it be the doctor for the appointment?
Yep, it is. The doctor table related to the appointments table. What is the common field?
I just got it from the PK.
Yep, the doctor ID. Now, when you start interviewing and when you start, so it's multiple ways y'all gonna have to start interviewing. One is you might get away with not having no tech assessment. If you do, thank God. But if you don't, then oh well, you're gonna be prepared to do it anyway. But one way you might have a tech assessment is it'll be somebody on the other end talking, and they'll just ask you random questions. Similar to like what I just asked y'all, like, well, oh, what's a primary key? Oh, what's a foreign key? How would you answer this? How would you answer that? Can you tell me the difference between joins? And, you know, those type of questions. Another one is sometimes you might have to write code live. It'll be somebody on the other end on the Teams chat, whatever they Zoom, whatever, and you'll just share your screen and they'll give you they'll give you the code or give you like a pseudo table and they'll ask you a business case with the expectation of you being able to write your syntax to answer it. Now, if you do come across a situation like that, literally talk through everything you're doing. And when I say talk through everything you're doing, I mean talk through it just how you're doing your data investigation and how Janisha was like, okay, that appointments table related to the doctor's table on that primary key. Talk through it. When you're doing your take assessments, go and say, okay, well, right now I'm doing my data investigation. I see that the doctor's table is related to the appointments table on that doctor ID. Just literally talk through it, because you talking through it and explaining your thought process is going to be your edge over somebody that can't explain what they're looking at or what they're doing. So that's going to be like your leverage. Because if you do that, it exposes like, okay, well, you know data passed. I'm just memorizing the syntax and I'm going to write what y'all need to write. Like, no, you understand it on a deeper level. So that's going to help you. So yeah, it is. It's the doctor ID. Now let's get into our very first use case. Now, y'all know, I'm going to tell you the database. We're in this healthcare system database, but I do not tell you the tables because I don't do that, because when you get your role and when you get into doing these tech assessments, no, it's not going to be set up to where it's like, hey, can you retrieve this data from the appointments table and filter on this condition? It ain't going to be X like that. So I try to train y'all in a way to where it mimics how it looks in real life and you had an expectation on how to navigate that space when you get to that point, because that's the whole point you want to offer. So that's the point. So I tell you the database. We're in a healthcare system database, but I ain't going to tell you the table. I do that so you can do your own data investigation, whether it is like expanding these columns like this and looking at your data, or right clicking and selecting your top 1,000 rows and looking at your data. Also, I actually have this up as well because the goal is not memorization. The goal is really you being able to like make a decision based on what you need and how to put it in there. So y'all ready? Okay. I'm gonna write the use case in the chat, and this is good for you to be able to document your code as well. And I'm gonna talk to you about that too. Okay. I need a list of patients who have had an abnormal MRI scan. Now, remember, when we're documenting our code, always document what you're doing. So come down here right on line 3 and come on line 2 and just document what you're doing, whatever you need. This syntax does X, Y, and Z. Just document your code. So first things first, data investigation. Which tables answers this question? I need a list of patients who have had an abnormal MRI scan.
Medical test?
Yep. So right click, select your top 1,000 rows, get rid of that top 1,000 because it's the limit. So get rid of that. and literally build your syntax on this. It already exists. Use this. Use this to answer your questions. But yep, it's the medical test table. Come through, Janisha. Oh, baby, you're not playing. Okay. Always remember, don't feel the pressure to reinvent your syntax. What already exists? Let's go and see what already exists and build upon it, layer upon it. Like Franklin Saint said, brick by brick. You literally are going brick by brick and you building on it. Don't try to reinvent it. It exists, it works. Now let's build on it. Make sure you document what you're doing too. What is that? Oh. And if you want to talk through something or share your screen, let's just do it like that too. Or if you have questions. Okay, let me see your code. Okay, so this Janisha code right here. Not quite. Let's talk through it. Y'all ready to talk through it, or y'all need a few more minutes? Janisha, you like 80% there. You not. It's not. It's wrong, but it's not like wrong.
Right place. Okay.
Yeah. So okay. So this Janisha's code here. Now she got select column from her table. You have this. This stays in your select statement, but it also goes in your filters. So you would say where test name equals MRI and what I say result equals abnormal. So you have it will say column name equals this, but it will be in your where in your condition.
Gotcha.
Also, this not gonna return no data. Yep. And it's not your syntax. Your code is right. Well, it's not this syntax. The syntax is correct. It did not return data because let's do our data investigation. Look at the values in that column. So your values in your where statement has to match exactly like how it is. I say and test name equals, and it'll be MRI scan.
Okay.
Yep. It's not. This is not. There you go. This is not case sensitive at all. Some dialects of SQL is case sensitive, but Microsoft is not. But it just has to be the appropriate values. But other than that, your thought process was right because you were like column name equals. That's 100% right because that is how you do your filters. But you just do it in your where.
Okay.
Yep. I'm gonna give y'all another one. Did anybody else have any questions? Tonky, did you have any questions with yours? Oh, I thought you were saying something. Let's do another one. Oh, let me pull it over here. Okay, one more. Provide me a list of female patients with the last name Johnson. Data investigation, which columns, which tables, and then select your top 1,000 rows and build on top of it.